Welcome back. We are looking at chapter 4.5, which is moment of a force about a specified axis from the textbook. Yeah, at the end of the lesson, students will be able to determine the moment of force about an axis using the scalar analysis and also vector analysis. Yeah, so using the scalar analysis, let's look at or before that, the application. The application is like in anything that need rotation. Yeah, rotation. Like example, look at this socket wrench. It's actually going on circular movement, right, with a force here, and then there is a what do you call the R value, the vertical the perpendicular displacement. Yeah, so causes moment, right? So yeah, another example, look at this one is like you want this rotation to actually go about a certain axis. Like example here, you want it to go about axis A. So for this, you want it to go about this axis, x-axis. So these are the things that you need to, this is the reason why you need to actually look at the chapter 4.5. Yeah, recall that the moment of scalar about a point O is F multiplied with D, where D is the perpendicular distance from the point to the force of line of action. This concept can be extended to find the moment of force about an axis. So this is what we are going to look at. Yeah, so in this figure, the moment about y-axis would be my equals to fz dx, which is actually equal to fr cos theta. However, unless the force can easily be broken into components and the dx found quickly, such calculations are not always trivial, and vector analysis may be much easier, yeah, and are less likely to produce errors. For example, in this case, you have an my. The moment is about my, but you want it to actually be around m naught. So you can actually transfer, vice versa. Actually, anywhere that you want it, or you find your m naught and then you want it to go around my, also can be done. Okay, so this is where we're going to look at. You know how to find your m, right? Where you get your r cross f. That's what we have done in the last lesson. Now, if you want it to go across axis A, then what you need to do is you need to find the unit vector of A. You dot with the m naught that you have calculated. You get what I'm saying? So there's two steps involved. First, you find the moment as usual, as the usual method. Then the second part, if you're going about axis A, so you take unit vector A, you dot with the answer that you have calculated. Yeah, when we do an example, when you solve an example, then you will understand. So the arrangement in the matrix will be the first line, yeah, unit vector for x, y, z, and then the second portion will be similar to what we have done before. Now, when you solve in your exam, I want you to do step by step. Yeah, so the first part that you should do is actually to solve the moment. So this is the first part. When you get the answer, only then, yeah, the second part, you dot with the unit vector. Now, the reason why I don't want you to do this in one go is because I'm just scared that you may end up getting into making careless mistakes, yeah, because it's a lot to calculate. So let's solve an example. Yeah, you will see how to go about it. Yeah, example in this lecture is rather easy, so I'm going to go into the textbook. Yeah, so let's look at the textbook example. Okay, so I'm looking at example 4.8 from textbook. Determine the moment MAB produced by the force F, which tends to rotate about axis AB. Yeah, so they want it to rotate about axis AB. Okay, so axis AB, which means you need to find the UAB, correct? Yeah, UAB. Okay, they wrote as UB, but it's actually UAB. So what do you do? Coordinate A is actually 0, 0, 0. Okay, so what you need to do is you need to take coordinate B, which is 0.4 in the x, yeah, distance 0.4, and y would be 0.2. Okay, you form the unit vector. Okay, so you've got the first part of it. Okay, now keep that aside. Okay, keep this aside. Okay, you've got the answer, just keep that aside. Now we are going to find the moment. So I'm going to erase this. Okay, so that it's clearer for you to see. Okay, now you want to find the moment about axis AB. So you have the force. Now how does it get connected to this? Okay, you can use either RC, RA, or anywhere along this line, correct? Yeah, the R can be anywhere along this line. So in this case, the easiest would be RD. Okay, why RD? Because this is the force and RD is this distance here. Okay, so that is the moment about point A, but not along AB. You understand or not? So now what we are going to do is we're going to do the first portion. Forget about the second the second portion. We're going to do the first one, which is RD cross with F. So once you solve RD cross F, then you take the answer and you dot with this. Yeah, you do step by step. You should get the answer, which is 72I plus 36J. Okay, so that's the working. Okay, so with that we have actually completed this subchapter. Okay, if you have any question, you can ask me during the consultation hours. Thank you.